Well, good afternoon, everybody. I want to welcome you all to the latest installation of our webinar series focusing on various advanced technologies. It's being sponsored by WIRES and its members. And for today, I'm really pleased to have representation from two of the WIRES members on a discussion related to dynamic line ratings. Happy to welcome Alex Hodling from LineVision, AJ Hall from AES. They're going to do a bit of a walkthrough about the nature of dynamic line ratings and talk a little bit about some of the uses associated with it. For those of you who are watching the webinar, when we get to the end of the presentation, I'm sure I'm going to have a few questions for them, but we also want to open it up to the attendees in the audience to submit questions as well. And you can do that while the presentation is going on through the question function, which is on the GoToWebinar control panel. It should be over towards the right-hand side of your screen. If you click on the questions section, you can submit a question there. And then we'll pass it along to both Alex and AJ, and they will, I'm sure, enlighten us all about whatever your inquiry is. So without any further delay, I'm going to go ahead and turn it over to AJ and Alex. You can both introduce yourselves, and we're all anxious to learn more about dynamic line ratings.
Thanks very much, Larry. Glad to be here with everybody. I'm based in Boston here at LineVision's headquarters, and I run the commercial organization for LineVision. And it's fun. This is going to be a good conversation. I know AJ really well. We have some great information to share. LineVision actually works with half of the utility members of WIRES, and usually I'm only speaking with people one at a time, but now we have a large group here, and we're going to be able to share some really good information. So thrilled to be here. Thanks very much, Larry, for organizing this. I'll turn it over to AJ, who will start our comments.
Sure, thanks, Alex. Yes, also happy to be here and have the opportunity to share some of AES's vision, some of the work we're doing to kind of accelerate the energy transition. Again, AJ with AES, I work in our New Energy Technologies office, so that's a group, a center of excellence, where we look at technologies that are going to be valuable in the future grid. So happy to jump into the presentation here on dynamic line ratings. Go to the next slide, please. So let's start big picture here. Our ultimate goal is to deliver solutions to accelerate the energy transition. And AES and LineVision both share this in our strategic vision. And dynamic line rating and other grid enhancing technologies are solutions that deliver on the energy transition and to meet the needs of the grid and our customers. Because AES is not just a utility or a renewables developer, we're both. And so we see value in incorporating GETS in all of our businesses. And really what we're going to talk about today and why we're starting big picture is this is not just another mousetrap or widget that we want to present here. This is really a solution as part of a grid enhancing technology solution that can achieve your targets of decarbonization. And that's whether that's integrating more renewables, meeting decarbonization targets, delivering clean energy to your customers. Dynamic line rating and other grid enhancing technologies are key solutions for that. And also, we're not just in an energy transition to renewables, but we view this as a transition from an analog grid to a digitally enabled one. And dynamic line rating, as well as other GETS, are digital first solutions that are leveraging that data to give us more control, more visibility into our grid. We move to the next slide. Okay, so what's the urgency here? What is decarbonization forcing, and what challenges is it bringing to the grid? You can see here the US or federal clean energy goals for electricity. You can see by 2035, right, is our stated target for the US, but of course, states, businesses, organizations may have even more stringent goals. And you can see right now we're delivering 40% clean energy with our grid today. But if we want to deliver 100% clean energy by 2035, we're going to have to connect more wind, solar, and other renewable resources 6 times faster and require a build out of 3 times the current grid. This is a huge expansion in transmission capacity and what AES has identified as one of the limiting factors in the energy transition, which is why we turn to GETS as a solution that can leverage digital technologies in addition to the transmission build out that we need. Next slide, please. So what's really driving this need for transmission capacity? You know, these on the screen here are the challenges that the grid is facing. It's load growth, right? From electrification of everything, from transportation of electric vehicles, heating, new load that we're seeing come into the United States through the industrial policy that we've seen in the Infrastructure and CHIPS Act and other policies, as well as data centers and new manufacturing to support the green industry, such as battery manufacturing, which we'll talk a little bit about later. And these jobs and these businesses require more energy. At the same time, right, we're transitioning to renewables, which we previously talked about. And these renewables are being located at places that our system doesn't have the capacity now. That our load centers are fixed, but our renewables are moving further away from those load centers, requiring more transmission. And also we have the proliferation of distributed energy resources, which is adding complexity to the grid, as well as customers' desire to participate in the grid, which needs grid capacity to serve this. So, how do we solve all of this while still maintaining, as you see at the bottom, a safe, affordable, reliable system? We really need an all of the above approach. We need to build wires, but we aren't going to get there fast enough. As you remember from the previous slide, we need to build decades of transmission in 12 to 13 years by 2035, right? So we need other solutions like grid enhancing technologies, and specifically dynamic line rating has been identified as one of those technologies that can most get us to the transmission capacity we need, which is why AES is working with LineVision.
AJ, I like the point you make about jobs. I mean, I think often we're thinking about the things you see on the screen, but really underpinning all of this is the economic development and being able to have that advance, but power it. And that's a big challenge. And I think each, niche within the industry has its own energy needs, but I'm sure somebody knows the actual stat. But I think to power AI alone with all the data center proliferation, it requires, I think, like 3x the amount of energy. I mean, this is something that is accelerating at such a rapid pace. And I wonder, I know you're very far ahead as a forward-thinking organization. I wonder if the amount of load growth that's coming is really fully recognized. I mean, you mentioned in your last slide, you kind of had that oh my gosh moment where you have all of this capacity coming and you need to build out. I don't know. I guess there's not a question there. It's more rhetorical, but it's a really big challenge for seeing.
Yeah, and
I'm sure you guys are too.
I'm glad you made that point, Alex, because that load growth is just kind of like the renewables and the geography challenges I was mentioning. It's not happening necessarily like these data centers are not necessarily locating right next to a 345 kV line, right? They're locating in areas where more transmission capacity is needed, and so it's happening stochastically. We can't, utilities and others that are trying to serve, renewable developers are trying to serve the energy to this new load are having to fight these transmission capacity challenges. And in these customers, the industrial load, the jobs that come with that have very fast timelines, and traditional solutions like building wires take longer than the 24 months that we're seeing that our customers require for building these new facilities.
And I would imagine, I mean, I know it's obviously a big project to put a new factory in place or a data center, but they have options on where to go. I mean, I think one of the things I really appreciate about our conversations is how customer centric you are, and making sure that you're able to attract and also maintain your customers, which I think is a big part of the story of grid enhancing technologies. I mean, renewables is a big part of it too, of course. I mean, I think people often think about the ability to have a more flexible, dynamic grid, which is very much what grid enhancing technologies are about. But I guess really at the core, it's about doing this core function of utilities. It's serving load reliably and with resiliency, and that's what this is. I like it.
Yep.
Great.
No, appreciate the comment. Thanks.
So let's talk about dynamic line ratings specifically for a moment. I mean, look, dynamic line ratings as a concept has been around for some time, but it really has only been in the past few years where the technology has reached a point of maturity, and of course, everything that we're discussing has reached a point where we can't do it any other way. So in a lot of ways, it's the perfect scenario to bring grid enhancing technologies forward. AJ, you mentioned this transition from analog to digital, and I think that's apt because it's very consistent with how we think about dynamic line ratings. It's about data. We really see ourselves as a data science company, and I think the story of dynamic line ratings is about data, because ultimately, if you're using sensors like we do and advanced analytics, you're going to be able to understand your grid better, which makes you capable of utilizing it to its full potential. So a couple of, I guess, basic things about dynamic line ratings for those of you who might be a little bit new to the concept. It's pretty straightforward. We are installing the sensors that you see in this image on towers, and we're using LiDAR, which is looking up at the conductors themselves. And we're collecting thousands and eventually millions of individual data points about exactly where those conductors are in space and time. So that's the data story. We're collecting all of this data. And what we're doing with it is we're able to look at it in such a way that we understand what the conductor temperature is across the entire line. We don't need to install one of these sensors on every tower. One every 2 to 3 miles is sufficient using ruling span to get a good understanding of what that average conductor temperature is. And the reason that that input or that variable is so important is because that is the limiting factor for the vast majority of lines. And if we can understand what the temperature is, we know how much more capacity we can load onto those lines. And so this is, I mean, look, this is consistent with how everybody around the world is rating their lines today. We're using standard CGRE and IEEE rating methodologies, but instead of using those assumed variables for outside conditions like air temperature or wind speed, we're actually using this data to inform exactly what those values are. And so with that, you have an accurate understanding of what you can do with your grid. And it's very consistent with everything that's happening in the industry already. Everyone on the call is beholden to FERC 881, and everything that you're doing right now to build the architecture to be able to ingest those 240 hours for an ambient adjusted rating is the exact same architecture that you can use for dynamic line rating. So a lot of the heavy lifting is already, it's either already been done or is in process. And by being able to add that last most critical variable, which is the wind speed, you're going to be able to benefit from that as well. So again, it's pretty straightforward as a subject, as a concept, but the application of it is so important because it unlocks so much potential for all the outcomes that we've been chatting about already. And we really see this as a way to actually build grid capacity. Next slide, Drew.
Hey,
so
Alex.
Yeah, please, AJ.
Yeah, we can go back one slide. I wanted to make one point that just build on what you mentioned about, what capacity, using the wind speed and on the variables to understand what capacity can really be delivered on the line. I think one point that we like at AES is what we can safely deliver on the line. What static line ratings do today and why they're widely used is because they're a conservative assumption of what can safely be carried. Why do we have line ratings? To prevent sag, and they could damage the conductor or harm civilians or trees or anything that could be under the line, right? And what this technology does, by knowing the true conditions in your line, your system operations has visibility now. It's that, again, moving to that digital, from analog to digital, you have visibility into your line, and so you can truly know what the conditions are, because there are times when your static rating could be actually greater than your assumptions. Your conservative assumptions may be wrong. Now that would be only 1% of the time, but there's a safety aspect here that fits within AES's values that we really liked in the technology.
Yeah, I'm glad you bring that up, AJ. I think I'm like the one person at LineVision who's not an engineer, so I always forget like the accuracy part of it. That is so important, being able to obviously benefit from the additional capacity, but it's important to know exactly what those conditions are. I like that.
Yep, thanks.
Great. Drew, here we go. So I mentioned this as a new way to build grid capacity, and AJ touched on this as well. It's really important that we see dynamic line ratings for where it fits in this broader needs assessment of the U.S. electric grid. This is not an either or scenario. This is not a question of either building new transmission or using dynamic line ratings. This is not a question of either reconductoring or using dynamic line ratings. This is very much an and scenario. So at the bottom, really the thinking here is it's about reinforcing with building, it's about expanding with reconductoring and building, but optimization is the point that really stands out here. And the reason it's so important to introduce this concept of optimization is because it allows you to do things that the traditional means of building grid capacity simply can't allow you to do. The first, it's serving load. Bottom line, it's serving your customers, but doing it in a way that allows you to connect them quickly, add power when they need it, when they're transitioning to data centers with AI. And it's showing customers that you're doing everything that you can. You're bending over backwards to make sure that they get their power reliably when they need it. They don't have to get in line and wait 5 years for capacity. Now, you may very well decide that, look, this data center, this core group of manufacturing or data centers, they're going to need more transmission lines. Great. But that's not going to happen for 5 years. So today we can deliver dynamic line ratings and get them that much more power as part of a broader plan for the grid. So it's about serving load fast. It's about making sure your customers are seeing the hard work that you're doing. It's about reducing costs. And I know that congestion costs aren't always directly felt by the utility, but ultimately utility customers pay those costs. And when it's your name on top of the utility bill, all of the costs that go into that really matter. And we're able to reduce the cost of congestion, or in some cases eliminate that by using the grid more efficiently. And it really allows you to be more nimble. So we mentioned all these use cases: data centers, manufacturing, renewable energy. You can think of DLR almost as a phase one of that plan towards a more flexible dynamic grid, where you are equipping these lines with technology to better understand them, better utilize available capacity, and make your customers able to get the energy they need today. But there's also a question of, where is this growth going to happen? I think, AJ, did you mention it takes about, was it 24 months to build a data center? Is that about right?
Yeah, I mean, we're seeing timelines 24, maybe 36 months at the most, from data centers as well as some of our industrial customers. Usually the first phase of the plant comes online within 24 months.
Yeah, and I mean, depending on where you are, those timelines don't always add up or equal. So the timeline to build new transmission can be a lot longer than that. So by the time they're ready and thirsty for electrons, they're not there. So again, this is when we talk about the energy transition, this is very much in service of the energy transition, being able to do stuff a lot faster. So anyway, think of this as really a new way to build this capacity. Again, in no way is this replacing the need to build more. I think it was last week there was an article in the New York Times that painted a really clear picture. I think all of us kind of appreciate it already, but it was just very stark and public facing that we do need to double and then triple the U.S. transmission grid. to AJ's earlier point, that can't happen economically, and it certainly can't happen fast enough. So this is the solution, the and scenario. But let's look at one short example on the next slide. AJ is going to be able to talk a ton about the work that we're doing with AES, which is a really exciting story. But I also want to highlight another project that we did with National Grid. And the reason I want to touch on this is because it's a bit different and it's interesting for a few reasons that highlight some of the attributes and benefits of DLR that aren't kind of bucketed in that last slide. So this was a project we did actually in the UK. We worked with National Grid in Massachusetts, in New York, but also the UK. This was a critical line outside of Manchester. And it's interesting for a few reasons. One, a lot of it has to do with operational control. So if you look down to the table in gray at the bottom, you see the static post-fault rating. And then a couple rows below that, you're seeing what the capacity increase is, about 30% on average. The reason this is important is because you're looking at the increase post-fault. So if there's either a line outage from an actual line or a grid problem, or if this is a planned outage that they have, what you're doing is you are mitigating the impact of that outage, whatever the reason, by being able to move more power on parallel circuits if you're using grid enhancing technologies. So this is putting more control in the hands of operators. And so this isn't just like an economic story or connecting data centers, it's also about more flexibility in the control room, which is a really important thing when you think about resilience and reliability. The next is about availability. A lot of people think, well, dynamic line ratings, it's dynamic. So like AJ said, 99% of the time you might have more power, but maybe sometimes you don't. It is important to be able to have that awareness. But you're seeing here in this example with National Grid, the amount of time that DLR was above static. Not all the time, but in the 97, 98% of the time. So when you think about what you can do with that, this has grid-wide impact. The vast majority of the time, your assets are being underutilized. And the difference between underutilizing them and using them efficiently really makes a lot of economic things possible, which is the last piece. And you see in the upper box there some of the outcomes. So it's cost savings. It's the ability to unlock energy, whether that's renewable energy or traditional sources. So when we talk with our partners, yes, there is an operational component to this. Yes, there's a safety component. Yes, there's a use case component around interconnections. But underpinning all of it, it's a really clean economic story about the impact to first customers, but also to the utilities. So this example, I think, highlights a lot of those points, and we'll chat now about, we'll go back to AES because that's a really cool story, but these are some of the more related components of what DLR can do.
Yeah, thanks, Alex. AES actually identified a lot of the use cases you just mentioned of resiliency and mitigating congestion. So yeah, I'd like to talk a little bit about just how AES has deployed the largest DLR project in the United States in our utilities in Indiana and Ohio, and kind of step through that process of identifying a problem and a challenge all the way to installing the sensors. So really at the start, it was to align what are the challenges we're seeing, right? So we talked about AES has identified transmission capacity as a major blocker to the energy transition and to maintaining affordability for our customers. So we have challenges such as economic development we've been talking about. So as a concrete example, in Ohio, we have a large Honda battery facility that is located in the southeast part of our service territory that has that 24-month initial startup time frame. The outages needed and capacity needed to facilitate that construction while transmission is being built. We're working on a 345 kV link that will eventually come in 2 to 3 years later. That was a major challenge for us, and we looked to DLR to help solve that challenge. So again, what's the vision, what are the problems you're facing, what are the challenges, and then it was identifying specifically which lines limit our capacity, right? And it may not be just a line. You may have another most limiting element, such as a wave trap or a switch at a substation or a midline switch that could be holding back 20% of the line's capacity, right? So it's doing that detailed review of your of the circuits that are limiting, limiting your challenges, like the ones the 69 kV system around this Honda plant, and identifying those problems. And then it was working with LineVision to scope the project. So we had a workshop in Ohio. We all sat down together, laid out these lines. LineVision was able to help AES understand what the DLR potential was on these lines, and then follow that up with a full line profiling study where we look at the historical weather data, the headings on each of the lines, looking at the KMZ files for each line to understand what are the potential capacity increases, right? And then we're seeing that anywhere from 20 to 55% over our static ratings for this project, across lines really from 69 kV all the way up to 345 kV. And once those line profiling studies are done, we then can kind of align, okay, where do we have good DLR opportunity with which lines were deemed the most critical, and of that we selected 5 transmission lines, right? And those are the ones that we've installed sensors on across Indiana and Ohio. And after that, the installation is pretty straightforward. It was completed in 2 weeks. So all 5 lines across both states were completed in 2 weeks, and you can kind of see the installation there on the slide, right? It's done with ladders, hand tools, and a crew of 3 to 4 linemen. And in fact, our linemen got so good at this that by the end, they were putting one up in 15 minutes. So it's something that is very quick to install, and it's very safe. Again, going back to the safety principle, this is a non-contact sensor. You can see it there in the line. There's no de-energization of the line. It's 15 to 20 feet up on the tower or pole. And so we were able to complete this without a transmission outage and done very safely. And then, after the installation, we're currently in the process of collecting the data. So, at the LiDAR is monitoring the transmission span. We're getting in the third-party weather data, and we're transferring line loading data into LineVision's line rating algorithm, right? And it takes roughly about 3 months to train that algorithm to start providing dynamic line ratings. And so we're looking to hopefully early next year share some initial results of this project, and ultimately continue monitoring these lines to understand where can we leverage these data insights for better planning, for integrating new customers, and expanding the reach of our DLR project. I don't know if Alex, you want to add anything there about our collaboration thus far?
Well, one of the things I think that everyone should take note of is that AES really did this in a good way. So that meeting that AJ referenced was the right way to do it. So there were a bunch of people in one room, and all of us really had the same outcomes in mind. And I think it's important to, and this might sound obvious, but it's really important to start with the goal in mind. And what are we trying to achieve? Is it serving that Honda battery factory? Is it serving these data centers? Is it incorporating the renewables? Because that obviously has a big impact on the execution of the project. And that focus allowed us to have an incredibly productive meeting. And I guess, AJ, for the people on the phone, you don't have to go through everyone in the room, obviously, but who would you recommend to others who are thinking about this? Who should be in that room? So what roles should be in that room to really put your heads together?
Yeah, sure. So this was a project within AES's utility. So, if I'm thinking of folks on the utility team, it's your transmission planning team. It's your transmission operations team. So this has a planning benefit when you're thinking about new customers. It's your interconnection team. if that's a separate group. It's also your customer, you know, representation team. So it's the folks that are reaching out to folks like Honda, right? Those folks should need to be involved in that meeting. And then it's also asset management and your energy management system or SCADA team, right? So there's a data integration piece here that to get these ratings into your energy management system, there is a data integration which AES is looking to do as part of an extension of this deployment to get these ratings operationalized. So those are kind of the ones that come to mind, Alex. I don't know if I missed anyone that you can remember.
No, I mean, I think you kind of forgot yourself in a way, you know, making sure that there's somebody who really is getting behind this and bringing all those people together. That's the critical person, I think, because obviously all those people you mentioned have their really important role to play. But if somebody isn't bringing them to the table, then stuff just doesn't happen. So your role is really key.
Sure.
You know, this is like my whole world, so I guess I don't have the broader perspective. But when you have done other types of projects like this, is that consistent with how AES operates, or was there anything unique about DLR or grid enhancing technologies?
No, I think it is kind of consistent with how AES operates. You're right. There is a project champion, right? There's someone that has the vision of the scope that needs to be done, and then a sponsor, let's say, of the project. I'd say those are the two maybe I missed, right? But no, I think that's how we operate. You know, one of our values is all together, and so we kind of pull in a large group of folks that maybe this project isn't their, you know, in their job description, right? But it is, everyone leans in to understand, okay, this is core to, and you know, accelerating our business and delivering things, you know, clean energy for our customers. And so yeah, I think it's an approach we've taken with other efforts within AES.
Yeah, I mean, I'm glad to hear that, because I think that from the a repeatability standpoint, this wasn't bespoke. This is kind of the way you operate, and so this isn't really changing that. It's just changing the focus for this specific project. I like that. You know, I also note that you mentioned what we call the DLR profiling studies, and like you said, that's a way for us to help our partners understand what the likely available additional capacity is going to be for parts of their grid. And that is a really good part of this process, because it de-risks this in a big way. It kind of lets you know what the potential is, and has you more informed going into the planning process for what you're going to be able to deliver. I guess it's kind of self-explanatory, but that's, I think, an important part of this piece.
Absolutely.
Yeah. I mean, obviously, you and I know very well that this was a pretty sequential process. But when we open this up in a few minutes for Q&A, I'd be interested in what other people on the phone think about the step-by-step process, and if that was clear and pretty straightforward. I think it was. But it's all about how you actually do it. I mean, the concept is there, the technology is there, but going through the actual chronology of how you get these things done is important. Drew, let's jump to the next slide. You know, it's important to make a few points here. One, I think it's pretty clear, is that dynamic line rating is ready. This is not something that lives in the innovation department anymore, and we've done that. We've come out of that and are really happy to be doing at-scale projects like the one that AES is leading. But 7 of the 10 top IOUs in the country are doing DLR as well. This is not an esoteric technology that people are kicking the tires on. This is very much out there. And those at-scale deployments continue. AJ mentioned that this project is the largest deployed DLR project in the United States. And it was our first project together too, which I think kind of talks to the readiness of this technology. It didn't need to go through that pilot phase. It was ready to go. So let's go, roll it out. And then we talk about the timeline. AJ touched on the speed at which this can be deployed. That 3-month timeline is really, as he said, the time it takes to capture enough data, to calibrate it, to make sure that the line rating is accurate and safe. But the ability to actually get data flowing, like AJ said, it's 15 minutes once the sensors are actually attached. A couple of things to note, and these are not insurmountable. I mean, there's maybe some challenges, but some things to note. AJ did touch on the data integration. That is something that has to happen. I mean, ultimately, you want to have the line rating information in your EMS, so your operators just have that additional capacity. There's no lookup table, there's no calculation. It's just there. They have it and they can use it. That does take some time from your IT and security teams. That data does start to flow right at the 3-month mark. So you will have access to what that dynamic line rating is via our platform. So you'll have it, and you could use it if you wanted to type it in manually. And that maybe is kind of a phased approach, but ultimately getting it into the EMS is something that has to be done. But as I said, FERC 881 makes you do it anyway. So it's that same architecture that you would use. It's not firm fixed capacity. I think that's important to note. 99% of the time that capacity is going to be there, which is great. And we have a service level agreement around delivering the DLR, but the DLR never defaults. So a common question I get is, okay, if we have a DLR, we're at 2,000 amps, and then for some reason we lose that, does it automatically default to the static rating? The answer is no. That drop would never happen. The DLR is always available, and so that's really de-risked the fact that it's not firm fixed. So the availability is very much there. But the last point, like anything that you do differently, there is some degree of organizational change that occurs. And I remember when I first joined LineVision years ago, I thought that the control room and the operators might be a little bit challenged around this, and they might reject it because it's changing how they did something for a lot of years. But the reality is, we are introducing a level of operational flexibility and control and accuracy, like AJ said, that they don't have today. So some of our closest partners, some of those relationships actually started from our communication with the people who lead the control rooms themselves. So while there is a degree of organizational change that has to happen, I think it will be well supported within the utility once it's fully understood. And then just in terms of the support here, obviously you can see that a lot of people are doing this. Like we said, more than half of the utilities who belong to wires work with LineVision, which is great. So there's a lot of industry support from your peers behind you. There's a lot of regulatory interest in this as well. And that's a really good thing, because making sure that you have the support of your regulators is really important. The solution costs 1/25 the price of new build transmission. And like I said, new build transmission is necessary, but this is a very customer friendly way to add that capacity fast. And that's what's driving a lot of the support for this. And I guess the last point on customer demand, that Honda battery factory that AJ mentioned, I've never spoken to them, but I imagine that AJ talks to them a lot. And if they need that power, this is a good way to demonstrate to them that we're doing everything possible to get it for them. And so this is also something that allows you, the utilities, to really demonstrate that goodwill and effort to your direct customers as well. So maybe we could pause here, unless AJ, you have any other comments before we kind of open it up to
maybe just 2 points on on the customer demand. Absolutely, I think AES sees it as a way to be competitive, like you mentioned earlier. These data centers are shopping around where they can build, and being a transmission provider or utility, they can deliver the energy within the timeline and albeit clean energy as well, to meet the goals of those the new loads coming into service territories. Like that makes us competitive at AES. So that's another reason we pursued GETS. And then on the organizational readiness, yeah, absolutely. I think there's anytime you're dealing with touching the transmission system and something new, it is absolutely there's some recognizable resistance to that change. But I think as our team has gone through that process that I outlined, they've leaned in further and further of wanting more of this flexible capacity. And really to the operators as well, Alex, you mentioned 881, the many utilities, including AES, are already working on compliance for that. And really dynamic line ratings from a plug and play to the EMS and what the operators will see, it's very similar. It's really just, instead of an AAR rating, you're going to see a DLR rating that you're operating on for that line. And that's also what the RTOs, whether we operate in PJM and MISO, and that's kind of what those regional transmission organizations will see as well, of what limits are passed along through the EMS. So yeah, I think there's definitely a component there that needs to be factored in the project, but I don't think, especially when you think about 881 and the work already being done, it's not a huge lift there on the data integration and organizational training piece.
I like that. What do you think, Larry?
Well, thank you, Alex and AJ, for that presentation. Really appreciate it. I found it really interesting, and it looks like I'm already starting to get some questions coming in from a couple of people. But while people are thinking it over, if you do have any questions, submit them in the question function, and I'll certainly throw them out there for Alex and AJ to respond to. In the meantime, though, I came up with a couple myself as we were going through the presentation, and I'd like to go ahead and start off with those while folks think about anything else they would like to add. And one of them, first of all, I want to tell you I really appreciated your last slide there, because you identify and you mentioned a couple of times that you, Alex, are working with about half of the WIRES members right now on using this technology. And I think that's really an important point, because I think it provides a different story than what I feel is a bit of a false narrative out there, that utilities just as a class are not using these technologies or are in some way hostile to them. In fact, the matter is they are being used, maybe not by everybody, but they're taking advantage of it out there. So I appreciate your flagging that. I guess the question I would start off with, though, is for companies that are looking at different needs and are thinking in terms of traditional wire solutions for them, how would those utilities be incentivized to implement DLR rather than using some type of a traditional wire solution? I'll let either one of you talk, or both of you even talk about that.
Alex, I can jump in first and you can add on, but so thinking, how did AES utilities justify the project, and how did we look at that question? Because absolutely, right, that a traditional, when you think about the rate of return, for instance, you earn on a traditional transmission investment of over something that costs 1/25th the cost, and dynamic line rating, it's not the same. That said, we see all of the above approach as absolutely necessary. We are seeing, and I think other utilities are seeing, there's a lot of opportunity for investment in the energy transition, but you need to manage and optimize that investment for your customers. And so dynamic line rating kind of builds that flexibility in your system, so that you can have, if you have DLR, you can manage someone that has a quick timeline to increase load while building the transmission investment behind that, and do that in a proactive way versus reactive. So you have the DLR for the flexibility, and you're able to kind of look at multiple needs versus react to them very quickly, and shocking your customers with higher rates required to earn the return on that investment. So I think that's how we looked at it. And then there's also a regulatory piece here too. And Alex, you mentioned there's support from multiple regulatory bodies, and we are seeing that as well. Again, this technology is the most efficient way to add capacity quickly, and our regulators are seeing that as a positive, right? As something we're doing for our customers.
I agree with all of that, and I think to underscore the "and" scenario is really, I think, the biggest takeaway there. Everything that LineVision does is our capital solution. So the hardware plus software is a capital solution in 100% of our cases. In addition, you mentioned the flexibility and nimbleness, AJ. There are a few scenarios where LineVision has installed on towers, looking up at lines that are slated to be reconductored within 24 months. But for the challenges that those lines can't achieve today, the additional capacity for the next 24 months that they're going to get is very much worth it. And so this is that nimble solution that doesn't replace the need for more transmission, but it gives so much more potential to lines, even if they are going to be rebuilt. And then I think about another project we did with New York Transco along the Hudson River, which is a really interesting one because it's the first project that has been done for dynamic line rating on a new line. So right when it was in service, LineVision is there. And so that's, I think, maybe better than anything, underscoring this "and" scenario, that you have new build construction, but you're going to future-proof it by equipping it with technology to be able to get that full potential out of that line from day one. And I guess just to be a little bit, I don't know, obnoxious, Larry, but you said traditional versus, whatever the opposite of traditional is. We are using the same methodologies that you are for rating your lines. IEEE 738's heat balance equation, that's a traditional way to get capacity. We're using the same equation. We're just putting true inputs in there, not assumptions. So I, of course, know the spirit of your question is about building or using DLR, but there is a large traditional component to how we're doing this. It's using the exact same methods that you're using. It's just giving you the actual available capacity for you to use. I mean, they're your lines. You should be able to use them to their fullest potential.
Yeah, I didn't think that was obnoxious at all, Alex, so don't worry. I want to hit a couple of the questions that have been coming in. One is, how would you approach or have you approached studying or applying DLR in an interconnection context?
Yeah, I can jump in here. So we have AES Renewables has not at this time used DLR as a means of mitigating, let's say, network upgrades in an interconnection study or project, but we are looking into that, right? So I think one of the things we're looking to do with this initial deployment and then scaling it up is collecting enough data to then say, okay, right, we've proven, and it's, as Alex said, DLR is proven in operations. But I think that jump, the next to the planning scenario, right, where you're actually planning future capacity with DLR, we see a future for that, but there is still more work to be done there. And I don't know if Alex, you have a comment as well, but that's moving again from your operations planning horizon to the system reliability planning horizon. That interconnection studies and reliability planning are focused on.
Yeah, there's a good amount of work out there that points to the benefits of GETs in service of accelerating the pace of the interconnection queues. There is a regional component to this, of course. I mean, I know when you're talking about like interconnections, that's a specific thing, but I think we need to think about DLR as not just something that's in service of this one data center. I mean, that tends to be a very common use case that we see, but I know, AJ, the utilities that are in your portfolio, and they're connected to lots of other utilities as well. And so being able to see this at a more macro level, at an ISO and RTO level, I think is really the next stage of growth, where it goes beyond an individual proximate challenge and starts to be something that can serve the grid at large. And I do think that FERC 881 will help with that as well. Obviously, the same criteria to which utilities are going to be held, the ISOs are as well, being able to adjust that data also. So I see this as really in the future how the grid operates. I think this will be a very standard technology.
Agreed, and I see that too. Of we're moving toward that, again, digitally enabled grid, and so planning will be done with grid enhancing technologies factored in. And when AES is working to push for that. And the interconnection, even, I think one step is it can improve interim deliverability. So a lot of projects can connect to the grid, but they might not be able to get full capacity deliverability until transmission upgrades or network upgrades are built. You can use GETS, kind of like Alex mentioned in the reconductoring scenario, for 2-3 years while you wait on transmission build out to be able to deliver more of your capacity of your renewable installation.
Okay, I got another question here from the attendee group, which is, how does Europe's static ratings compare to the US? And they're particularly wondering how the solution managed a 30% increase.
How the solution managed a 30% increase. Well, that in the case of National Grid, the case study I showed, that was the average. In AJ's cases, I think it was between 22 and 50%. A lot of it has to do with the current assumptions going into it. So for example, when you're using static assumptions in your equation, depending on how optimistic you are about wind speed, that's going to have an impact on the capacity gain. So if you're assuming that the wind is never blowing, you're going to have wild gains in capacity once you actually realize the benefit of that wind. If in your model you're assuming a higher wind speed naturally, which might be dangerous if it's too high, your gains may not be as high, because a lot of DLR is going to be based on the cooling impact of wind. So that 30% is going to be dependent on that. It's also going to be dependent on the terrain. So for example, if you, and we do have a couple instances where there's a transmission corridor right through forests, like you're not going to be able to realize as much of a wind impact if you're not going to have that perpendicular wind. So the terrain matters as well. But that is why, and AJ mentioned this, the DLR profiling is so important, because we're looking at an incredibly granular level for every span. How is the wind going to be impacting that span? So you'll be able to have an understanding of what that likely gain is going to be in advance of any project, whether that's 30% or 50% or 20%. So I guess that's kind of the variable aspect of it. And in terms of the static ratings in Europe versus the US, I mean, I'm not an expert in the control rooms. I don't see a difference. I mean, it's the static rating is an assumption based on CGRE, just like we have our static assumptions here. I mean, by definition, it's just your assumed ceiling for how much capacity you can put on the grid.
Well, Alex, AJ, we're getting pretty close to the top of the hour, but I want to get one last question in before we bring this thing to a close. At last week's fall wires meeting, we had a session that we called our crystal ball session. So I'm going to add a little element of that to this webinar today. So if we break out the wires crystal ball, if you're looking ahead over the next 5 years, how do you, the two of you, see the use of DLR impacting the grid over that time frame?
I can go first, Alex. So looking at my crystal ball here, Larry. So I mentioned that, you know, the transition from analog to digital. So DLR is one tool in the toolbox of grid enhancing technologies, and I would even add storage and transmission. All of these alternative transmission technologies. How are we going to address that that capacity need. And we see a suite of grid enhancing technologies to being used in interconnection, in serving load, in and moving into that planning horizon, because we are going to, the grid is changing, the not just the renewable sources of energy, but the more inverter based resources we get on the grid. We're able to, control for voltage and stability, differently than we have in the past. We may not need as many spinning reserves with the ability of creating synthetic inertia in the grid. So all of that, I think, will need to start being incorporated into the transmission planning and investment process. And so that's kind of the future that AES is looking to drive here with our project in DLR and our work with other grid enhancing technologies. Alex, I'll let you jump in.
I like your crystal ball, but I guess what I'd add maybe is there is nothing in our life, in our world, that is receding from a data standpoint. What data informs is getting more and more vast, and there should be no expectation that how we manage our grid is going to be an exception. And by being able to have a more data informed path toward solving all of these challenges, that's what's going to happen. I don't really need a crystal ball for that. I think you just kind of need logic on that one. But I think that there will be an expectation around this from your customers. I think there'll be an expectation from your peers that these types of technologies, grid enhancing technologies, and DLR specifically, are being used to achieve these challenges, because I think we'll find very, very soon, if we haven't already, that everything that needs to happen just simply cannot happen in the pure traditional way. So this is going to be elevated by sheer necessity, if nothing else. And that's, I think, also pretty logical.
Well, great, gentlemen. Once again, time has absolutely flown by on one of these presentations. I apologize to folks if we didn't get to all the questions that came in, but AJ, Alex, want to really thank you for the presentation today. Found it very informative. For our attendees, I want to give you a little bit of a preview. Our next webinar is going to be on December 13th. We're going to have WIRES member Medox do a presentation on high temperature superconducting wires. So please plan to join us on December 13th and learn more about yet another advanced technology that we use within the transmission infrastructure building process. So thank you, gentlemen. Appreciate it. Thank you, everyone who tuned in, and look forward to seeing everybody next month. Bye now.
Thanks, Larry.
Thanks. See everyone.